Okay, so numeration systems with different bases. What do I mean by numeration system, and why is it that sometimes I use the word number and sometimes I use the word numeral? So numeration, it's the process of assigning symbols to numbers. So a number is something, abstract. It's like this many, you don't teach people what the numbers mean by explaining it. You just show them lots of examples, and after a while, okay, they get it. That's 3. All right. So the number is something abstract, and the numeral is the symbol that you write on paper to stand for it. And so you can have different numerals in different systems for it to stand for the same number. Okay. Now, your familiar system is this Hindu-Arabic base 10 place value number system. Okay, but for some other purposes, especially with computer science and digital electronics, other base systems 2, 8, and 16 have proven more useful. And the choice of base 10 was completely arbitrary. Maybe it's because we had 10 fingers, I don't know. The Hindu-Arabic system used that, and the Chinese number system used that. So we're used to base 10. As I'm going to start out, I'm going to write down something about how the base 10 system works for comparison. And then I'm going to do another example. Okay. So, here are the powers of 10. Okay. There's 1,000, then 100, and 10, and 1. And if I write a number like like 2,357, you all know from your youth that it's 2 times 1,000 plus 3 times 100 plus 5 times 10 plus 7. So we only need the 10 different digits, 0 through 9. And depending what place you put them in, they're worth different amounts. Okay. Now, how about a base? I'm going to do like a base 5 system for comparison. Okay. So if I wanted to make numbers based on with a base 5, then instead of needing 10 different symbols, okay, 0 through 9, so instead of having to have 9 different digits to work with, if I wanted to have only 5 different digits, I could I could use these for my digits. So we just have 5 different symbols. Now, how do you count? Well, you count up to 9 in base 10, and then you run out of symbols. So you start a new column. So you get up to 19, and you've run out of symbols. You don't have any after 9, and so you start a new column. You just, where you had a 1 before, now you crank that up to a 2, and you keep going. And when you finally come to a 9 in the second digits, you know, in the tens place, you've run out. So you add a new place, you go up and start using the hundreds place, and you know how it works. You've been counting all your life. Okay, so what would you do if you only had 5 symbols? So you'd go up to D, and then you've run out. My D and my 0 look a little bit alike, but you see when you're after you run out, you come to D, then you got to start a new column. So you use A, A0, AB, AC, AD, and then B0, BB, BC, BD. And you've run out again, so now you go to the C's. When you get up to CD, you've run out again. You go to D. And now you can't go any higher in your 5's place. So you add a new column. So forth. You do all those AOs until you run out, and then you start with A1s. Well, AAs. Okay. So that's how you count. You just pick how many symbols you want to invent. 10 if you're looking at your fingers, or 5 if you're only looking at one hand, or if you'd like to really minimize the number of symbols, get it on down to just 0s and 1s, you could have a base 2 system. We'll do that later. Okay. So that's how you do the counting. So let's do a couple of problems where we convert numbers between the 2 systems. So I want to take the number 27 and convert it into base 5. And I'm going to use these symbols for my digits. Like 0, 1, 2, 3, 4. I could have used 0, 1, 2, 3, and 4. But there's a little confusion that happens. Sometimes people misread the numbers, when I use the same symbols in both systems. And so I'm trying it this way to see if it prevents that. So these are going to be my symbols. Okay. So now the question is, what's the biggest power of 5 that fits into 27? So you can get one of these groups of 25 in there. Okay. So I think of the 27, it's one group of 25. And no 5s. And 2 1s. So now looking at my digits here, I got, these would stand for 0, 1, 2, 3, and 4. So I have one group of 25. Zero groups of 5. And B groups of 1. Okay, 1 is A and 0 is 0. And 2 is B. All right. So 27 in base 10 would be A0B in base 5. Now there's this notation that your book uses. Now they'll add the word 10 as a subscript there, so you know what base it's in. So 27 base 10. And then they would say, (102) base 5. Okay. So you don't have to make up completely new symbols. Okay. But people misinterpret that, and they think, I mean, I hesitate to even say it because I don't want you to think this. But, last time I was teaching this a couple of years ago, people were thinking, oh, he's asking me to take 102 and convert it into base 5. No, there's no 102 here. There's not any of that. That's why I was writing the AOB, so you would never think 102. Okay. Because the number we're talking about here, it's that many. 2 more. Okay. So that many. No. It's 2 10s and 7 1s, or else it's 125, no 5s, and 2 1s. So this is not 102. It's 102 in the base 5 system. Okay. So let's do a bigger number. Let's do, I don't know, 359. Okay. So we start at the high end and we ask how many 625s will fit inside 359, and there are not going to be any 625s, but we can get 2 or 3 125s in there. Okay. Let's see if we tried for three 125s would make 375. That's too much. That won't go. Okay. So we can only fit 2 of them in there. I'll do a little scratch work here. See, I do how many 125s will fit into 359. There's 2 of them. With 109 left. Okay. So there are 2 of these 125s. 5 cubed is 125. Right. So now we still have 109 more left to go. So how many 25s can we fit in there? Okay. So now we have 9 more left. How many 5s will fit in there? And then we have 4 1s left at the end. 4 1s. So So 359 base 10 is is 2414 base 5. Or if you preferred to use the letters, it would be B, D, A, B. Okay. Bada boom, we're done. So let's see, maybe we can do one that goes the other way. It's easy enough. Let's see, we'll make up a base 5 number. Did I make up a good example? No. No. Why not? That 7 there has got no meaning in the base 5 system. We've only got 4. We got 0, 1, 2, 3, 4. We've only got 5 symbols in all, not 9 of them. You know, we can't get up to 7. Okay, that's not a base 5 numeral. So let's make our number 2134 base 5. Okay. So that's so the place values. This is 1s, 5s, 25s, 125s. So let's see, we got 250 plus 25 plus 15 plus 4. So that's so 2 10s, 9 1s, I mean, 2 hundreds, 9 10s, and 4 1s would be the same as 2 125s and 1 25 and 3 5s and 4 1s. Two different ways of writing the same amount. That's why I can write an equals between them. You know, they stand for the same number. Two different symbols standing for the same thing. That's when you can write an equals. Okay. Well, that was the example with base 5. Now, I want to get over here in the mini lectures and materials from Module 6. And I've posted some videos over here for the base 8. Here's base 16. Here's base 2. And a thing from Khan Academy down here on just number system, different base number systems in general. And so they're giving you kind of the same kind of explanation that I just did with base 5, but you'll see it with other people's words in several different bases, and you'll get the idea of how it works, I think. So be sure, before you try the 6.3 homework, to go and watch some of these videos. And then in the textbook, in 6.3 here, the way they organize it is they'll convert various different bases into base 10. So that's one section. Try it with just different bases going to base 10. And then their other chapter is, okay, we'll take various different bases and we'll go from the other base into base 10. This converting directly between computer bases, it's kind of cool, but I think unless you're going to do computer science, you don't really need to go there. But you can go straight from 8 to 16. You don't have to go through 10 in between. And so these last two topics here, there may be like one question on the WebAssign homework or small number of questions. And you can look in the book when you do those, but it's not something you need to kind of memorize, or there's not a big idea for you to take to heart there, you know. And I didn't put that in the activities. So be sure to do the usual reading the book and going through the examples from the book. Okay, I'm going to stop the recording for a minute. I'm going to do your questions, maybe on other topics or this. And then I may come back and go through the book chapter page by page a little bit. But let's go ahead and make sure we can get your questions in. So I'm going to stop the recording for a minute.